Number 64. We have squares and an equilateral triangle, and we're just trying to find the ratio of the side of the small square to the side of the large square. So on ratio problems, what I like to do is take the denominator of the ratio and just set it equal to 1. So if big A is equal to 1, then all I'm really solving for is little a, the side of the small square. All I'm really solving for is this. So if this side is 1, then we know that all the sides of the square are going to be 1, and this side is also a. So these two sides together, these sort of bases of these little triangles we have here, together it's going to be 1 minus a, which means that one of these bits is going to be 1 minus a divided by 2. So if we have this, then we're going to use a 30, 60, 90 triangle to solve the rest of it. So here we have a 90-degree angle. Here we have a 60-degree angle, and we know this because it's the corner of an equilateral triangle. And then we know this is 30 degrees because it has to be for there to be 180 degrees in this triangle. So in general, for a 30, 60, 90, here's our 30, 60, 90. If this is 30 degrees, this is 60 degrees, and this is 90 degrees, a right angle, then if the side opposite the 30-degree angle is x, then the side opposite the 60-degree angle will be x times the square root of 3, and the side opposite the right angle is going to be 2x. So from here, we can just use these ratios to solve our equation. So the side opposite the 30-degree angle is 1 minus a divided by 2, and the side opposite the 60-degree angle, well, that's just the side of the square, and that's just a. So we know that if we take the 30 side and multiply it by the square root of 3, we get the 60 side. Or in other words, 1 minus a divided by 2 times the square root of 3 is equal to a. So I'm going to put this in the solver, and we can find out what value of a this works for. So 1 minus a divided by 2 times the square root of 3 is equal to a. We get a value of a of 0.464. So 0.464. Sweet. All right, let's move on to number 65. So we have an equilateral triangle and a scalene triangle. So we're looking for the side length of the equilateral triangle, and we know that this length right here is 7.33. So we know that, but we also know that AB right here is trisected. So my pen is being a little bit mean to me. So we know this part is 7.33, and if the side of the equilateral triangle is x, then this bit over here is x divided by 3, because it tells us that line AB is trisected, or divided into 3 parts. So for this, we can really just use the law of cosines. So this is x over 3, and similar to the previous question, we know that this angle has to be 60 degrees because it's an equilateral triangle. So you notice we have 3 sides and an included angle, so we can just set up an equation. So law of cosine says that a squared plus b squared minus 2ab times the cosine of the included angle c is equal to c squared. Or in other words, x squared plus x over 3 squared minus 2 times x over 3 times the cosine of 60 degrees is equal to 7.33 squared. So I'm just going to put this in the solver real quick, and we can get our answer pretty easily. So menu 3(1), x squared plus x over 3 squared, not x minus 3, x over 3 squared minus 2 times x over 3 times the cosine of 60 degrees. And also make sure you're in degrees. I know I am, but always double check, because that's a really easy way to get a problem wrong. And that's all equal to the opposite side squared, equals 7.33 squared. I'm solving for x, and we get a value of x of 8.31. And let's just double check that's what we're looking for. Yes, it looks like I set x equal to the side of the triangle, and that is what we're looking for. So we get a value or an answer of 8.31. 8.31. All right, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.